Okay, question 5 again. We have this equation here, f of x equals x cubed plus 8x minus 19. And part A is to show that f of x equals 0, solution between x equals 1 and x equals 2. Okay, so this one's relatively straightforward. Probably don't even need to put the numbers in the calculator, but we look at f1, that equals minus 10, f2 equals 5. We have a sign change, and we also know it's a continuous function. Therefore, a root between 1 and 2. Okay, part B, and we're going to start using Newton-Raphson this time. So, formula for Newton-Raphson: x n plus 1 equals x to the n minus f of x to the n over f dash x to the n. So in this case I'm going to need to differentiate. I have f of x equals x cubed plus 8x minus 19, f dash x equals 3x squared plus 8. Now again, this lends itself to a calculator. What's it asking? It's saying that x0 equals 2, so I can put all this lot into a calculator. Let's start off by defining x. Store as x, so x equals 2. Okay, you can put the formula in now, which is going to be x minus brackets x cubed plus 8 x minus 19 all over 3x squared plus 8. So that's set the Newton-Raphson up. We've got 2 in there already, and so x1 equals 7 over 4. And I've got to apply 2 applications, so using a calculator that's very straightforward. Just store that as x again, back up to the formula, 951 over 550, and it wants the answer to 3 decimal places, so that's exact, and that equals 1.729 to 3 dp. Okay, part C is working on from part B. It's asking us to show that the answer we got from part B, which is x is 1.729, is accurate to 3 decimal places. So what I'm going to do with that is do another upper and lower bound consideration. Upper bound to 3 dp, let's do f of 1.7295. And from a calculator that gives me 9.23 times 10 to the minus 3. Lower bound, f of 1.7285, and that is minus 7.74 times 10 to the minus 3. Okay, so we've got sign change, and we know it's a cubic, so it's a continuous function. Therefore, a root at x equals 1.729 to 3dp. Okay, part D is slightly more interesting. It's got to show that f of x equals 0 has only one real root, and it's using differentiation. So let's have a look. F of x equals x cubed plus 8x minus 19. I want to differentiate it. F dash x equals 3x squared plus 8. Okay, how does that help us? Well, let's have a look at TP. F dash of x equals 0, so 3x squared plus 8 equals 0. That gives me 3x squared equals minus 8, x squared equals minus 8 over 3. No real solutions to this. Therefore, no TPs. Again, how does that help us? Well, we know it's a cubic graph. Let's just do a bit of sketching and see if that can help us in any way. Okay, we know from the function here that the graph must cross the y-axis at minus 19. We've already worked out that there is a root at 1.729. It's a positive cubic, so we know it heads off up here, and we know it heads off down here. Basically, what's it going to look like? Well, we don't know exactly what it looks like, but there are no turning points, and we've all got a lot of information together. Going to look something like that. What I do know definitely, though, is I don't know what it looks like exactly, but knowing there's no turning points, there can only be one crossing point at 1.729. So there's no turning points, therefore only one x-axis crossing, so only one solution.